All right, I lied. We're not going to do an example yet. I forgot about horizontal translations. So let's take again, look at our function. We have y equals f of x, that's our function notation. We've got k, which equals a positive real number. Now what about, we talked about vertical translations, up and down, right? And that affects the y value, so we're doing something to f of x. And so remember, we're adding or subtracting outside the function, right? But what about a horizontal translation? Now horizontal means that we're moving left or right. So what variable or what coordinate are we affecting when we move left or right? That's going to be the x coordinate, right? So if we look at the coordinate plane, right, the x-axis goes left and right. So in order to move a point, let's say xy, some point from here to here, right, or from here to here, that's affected by a change in the x-axis. Okay, so how does that look? Okay, now, so that means we're adding or subtracting a value to or from the x-axis, which means we're inside the function. So that means that we're doing f of x plus k, or we're doing f of x minus k. Okay, now this is where students mess up because they think, oh, just like with the vertical translations, hey, when I added to y, right, when I added to the y-axis, or when I add a constant outside the function, that moves the graph up. And if I subtract a constant from the function, outside the function, then that moves the graph down. Okay? That makes sense. And then they go to apply the same reasoning to this and say, okay, well, if I'm adding k to the x value, that means, oh, I must be moving right. And if I'm subtracting from x inside the function, oh, I must be moving left. Okay? That is not true. It's actually the opposite of what you would think. And to see this, think about a function. Let's just take let's take the basic quadratic function. Let's take f of x equals x squared. Now the easy thing to do is always look for the intercept, right? So here the intercept is the vertex, which is at 0, 0, right? So when x is 0, y is 0, okay? And so let's say I want to graph the function f of x plus 3, okay? Now the easy thing to do is say, okay, well what does that do to the vertex of the original function, my parent function? So what happens is, okay, where is this function going to equal 0? So it's 0, the function is 0 at 0. But where is this function going to be equal to 0? Well, let's set it equal to 0, right? Or better yet, when x is 0, where is the y-intercept? So the y-intercept here is 0 when x is 0. But if x is 0 here, what do I get? I get 3 squared, which is 9. So what happened? Okay, well, when x is 0, it's 9. Okay, but what happened to this point here? What happened to the vertex? Well, the vertex should still be at 0, right? So we've got 0, right? So what happened here? When is this function equal to 0? Well, let's figure it out, right? So this is x plus 3. So we get x plus 3 squared equals 0. And so if we take the square root of both sides, right, we get the same thing. We get x plus 3 is equal to 0, right? Because the square root of 0 is 0, and this just gives you this. And there's no such thing as plus or minus 0, okay? So now what I'm going to do is I'm going to subtract 3 from both sides, and I get x equals negative 3. So what happened to the vertex? When y is 0, what x is negative 3. So what happened? Well, this point moved to here. And so now this point here at 9 moved 3 units to here. And this point here moved 3 units to here. So it actually moved the graph to the left. So when you add a constant inside the function, when you're adding to x, that results in a horizontal shift to the left. And also, if we were to subtract, we would find that it would turn into a horizontal shift to the right. Okay? So this implies left shift, and then if you subtract, that is a shift to the right. Okay? And you're still affecting the x-coordinate, but the result of the graph is opposite what you would think. Okay? So now we'll do some examples.